Hello Biochemians, Jason Matthew from Trinidad and Tobago here, and today we're going to be trying something new. I call this segment Biochem Bloopers. And basically what we're going to be doing is that we're going to be looking at past paper questions. We're going to be looking at what students have written and see where they went wrong and learn from their mistakes. So please, this is a forum for us to learn from students' mistakes. We are all written the exams and we have all made mistakes. The point here is to learn from them. So in other words, we will not tolerate any negative comments here, please. This is a learning process. So we are not here to criticize, we are here to learn. So let's get started. So today we're going to be looking at a question based on the Afinsen's experiment. And please give this question a read. Alright, what I encourage is that you write down this question. So pause the video here and write down the question at least. So we're going to be looking at, in Afinsen's experiment, ribonuclease was treated with 8 molar urea in the presence of beta-mercaptoethanol. There was a loss of catalytic activity. After dialysis, the ribonuclease regained its catalytic activity. Explain this experiment by addressing the words which are underlined and bold. What is the general conclusion that can be made from this experiment? And we give 10 marks there. Alright, so please write down the question, and pay attention to what's underlined and in bold. So just to make sure that you are following your orders, Biochemians, again, press the pause button, pause for a cause. Go back if you have to and write down the question. And I want you to spend some time and answer that question on your own. Alright, so do not cheat, do not go forward. Pause right now, look at the question, and you write down an answer to the best of your ability. I also want to point out that if you're having problems with this topic, that go back to the Biochem GM YouTube channel and you'll see videos on proteins and amino acids, and those videos will help you with this question. So if you think your Biochem Kung Fu, especially in this particular area, is a little rusty, go to those videos and check them out. Go to your textbooks, read about the Afinsen's experiment, do some research. But the important thing here is that you try this question on your own before we proceed. Also pay special attention to mark allocations, and only when you're happy with your answer, then should you proceed. So just to remind you, this is the question we're going to be doing, and we're going to be addressing the things that are underlined and in bold. And what we're looking at here is the Afinsen's experiment. So this was one of the answers a student gave me, and you can see they didn't really get the 10 marks because they really missed the boat on this one. So they start off by saying that beta-mercaptoethanol is a catalyst, which is entirely wrong. And they're saying that the urea is a coenzyme, which is also wrong. And how dialysis is a process of breaking the bonds. All these things are incorrect things to say. So the bottom line here is that these are actual student responses. And it also means that this could be your response. So you'll be learning from them. So if you have something like this, well, you see the mark you're going to get. So please know that these things are misconceptions, these things are wrong. This is what someone else wrote. And you see there, basically there was nothing there I could give marks for. Alright. So these are common things that people write, and you shouldn't have these things. Now, for this now is like, some people think that when they're in the exam, if I write plenty, that that I'm going to get some kind of marks. But the bottom line is that we all have a mark scheme, and if you don't give the points, you can't get any marks, whether or not you fill up the answer booklet or not. So if you read through this, you would see that there's nothing substantial there. Although you're writing a lot, there's nothing there to give marks. So you have to be very careful about that in the exam. Don't be filling up your booklet with unnecessary stuff or just writing irrelevant stuff. You're not going to get any marks for it. You need to give the points. Alright, again, but this is the same person. They have filled up their booklet, they are writing a lot of stuff, but there's no way to get marks. Alright, this person as well with the general conclusion. You can give it a read through and see how your answer matches to this one, and you can see that there's nothing that I can give marks for. Right, so let's go back to the question here. We are looking to address the things that are bold and underlined. So we have seen some errors along the way. Now let's see how your answer matches up to what you should have. Alright, so let's look at some key things here. Now you wouldn't get any marks for this, but the first thing I want to point out is that you are looking at the Afinsen's experiment. And if you did your reading, you would know that we are looking at the denaturation and renaturation of proteins. Alright, and specifically we're going to be looking at this protein here, which is ribonuclease. It's an enzyme. Now the things you're going to be getting marks for. Now let's look at this. The first thing you were supposed to address was the 8 molar urea. What is the role of 8 molar urea? Alright, so first of all, you should say that the 8 molar urea is a chiotrope. Alright, so that's the first thing you want to talk about. So if you had that in your paper, you're on an excellent start. The urea is a chiotrope, but you just can't leave it hanging like that. You need to explain what a chiotrope is. And basically in your explanation, I'm not going to write the details of it. You know, this is for you. I'm just going to give you a little skeleton here. But basically the main point you want to drive home is that chiotropes, they disrupt hydrophobic interactions. Alright, so a chiotrope disrupts hydrophobic interactions, and that is extremely important because we know that there are a few forces that keep the tertiary structure of a protein together, but the most important one is the hydrophobic interactions. Once you disrupt the hydrophobic interactions, you're going to be disrupting the tertiary structure of the protein, and we'll talk a little bit more about that later on. Let's go to beta-mercaptoethanol. Now there are a few things about beta-mercaptoethanol that you need to point out. First thing that you're going to start off with is the beta-mercaptoethanol is a reducing agent. So say that. So say that beta-mercaptoethanol is a reducing agent. Alright, so we have beta-mercaptoethanol is a reducing agent. Now what does it reduce? You know, a lot of people would have said in the exam that beta-mercaptoethanol breaks bonds. You see, this is a biochemistry course, you have chemistry involved. You just can't just say break bonds. How does it break the bonds? Alright, well, it reduces them. And what is the bond that we are talking about? Well, we are talking about disulfide bonds that are being broken here. So you need to say that as well. So let's put that. So say you are reducing disulfide bonds. Alright, so it's a reducing agent and you are reducing disulfide bonds. Alright, so we are getting some here. Now, where these disulfide bonds formed? Well, these disulfide bonds are in what is called a cysteine. Alright, and one cysteine is made up of 2 cysteines held together by this disulfide bond. So when you reduce the disulfide bonds, you get 2 cysteine residues. Alright, so again, you know, this is again basic proteins, but you should know the difference between cysteine and cysteine. Alright, need to work on this tablet writing here. Alright, so you have cysteine and you have cysteine. So one cysteine, when you reduce the disulfide bond, you're going to get 2 cysteine. Alright, and you could even demonstrate that. So you have a disulfide bond, and it's going to be reduced to sulfur hydryls groups. So you can put that here like that. Alright, so that is a few things about beta-mercaptoethanol. So let's pause and regroup here. Alright, so you're supposed to say that the urea is a chariotrope, and say what that means. It means that it disrupts the hydrophobic interactions. The beta-mercaptoethanol is a reducing agent. It reduces disulfide bonds, and these disulfide bonds are formed in cysteine. Alright, and when you reduce the disulfide bonds, you get 2 cysteines. So you have the S here. Alright, so this bond here between the 2 sulfur groups here is a disulfide bond, and if you reduce it, you get 2 SH groups here coming up. Alright, so how you all measuring up so far? I hope you all got all of this down. Again, this topic is discussed thoroughly in the proteins and amino acids videos on the Biochem GM channel. Also, please go to your textbooks, check it out on the internet, look at other videos, get that full all-round knowledge on this topic. Okay, so let's continue now. So here we're looking at loss of catalytic activity. So as a scientist, that tells you we're dealing with an enzyme is losing its catalytic activity. It means something is happening to its active site, its tertiary structure. Alright, beta-mercaptoethanol combined with urea is denaturing the protein. And what does that mean? It means that the tertiary structure, so we should write that. So you should have a note somewhere that the tertiary structure is being affected. Alright, it's the enzyme is losing its tertiary structure. Therefore, what's happening when you lose the tertiary structure? The active site, so let's make that note, the active site is losing its shape. Alright, therefore the enzyme is losing activity. Now here's the next thing, dialysis. Now dialysis is not a chemical as some people will suggest. It's a process, it's a separation, it's a process in which we can use as a method that we can separate proteins. Alright, well in this case we're going to be separating the denaturants from the protein. So there are a few things that we need to point out. The dialysis tubing itself is semi-permeable. So and the reason for that is that it has pores. Alright. Now these pores will allow molecules of a certain size to pass through. So in this experiment, the urea, alright, as well as the beta-mercapto, and you leave the rest, ethanol, I'm right at this, beta-mercaptoethanol, they are small enough to pass through. They are small enough, the urea and the beta-mercaptoethanol is small enough to pass through the pores of the dialysis tubing, and therefore they go into the buffer. And this process is via simple diffusion. Alright, so it's going along a concentration gradient and it's going through the pores. But the protein now, which in this case is the enzyme ribonuclease, alright, so ribonuclease is too big. Alright, so this protein is too big to pass through the pores of the dialysis tube. So the protein, the enzyme ribonuclease, remains inside of the tubing. Alright, so now you have what dialysis effectively does is that it removes the two denaturants, the urea and the beta-mercaptoethanol is removed, and you have the ribonuclease, the enzyme, it's remaining in the dialysis tubing, so it's being separated from the denaturants. And we see that when we do this, you get the ribonuclease regains its catalytic activity. And the reason why it does that is simple. Alright? It regains its catalytic activity, which is spontaneous thing, because once you remove the denaturants, the ribonuclease protein, it spontaneously regains or refolds into its correct tertiary structure. So you have refolding, right? You have renaturation taking place, a spontaneous process, and you get back the tertiary structure. So the tertiary structure is formed once more. So it means that the active site regains its shape. All right. So the active site regains its shape. And because of that, the substrate can now start back binding to the active site. Because the active site has its proper shape, the substrate can bind to it, you get a reaction. So finally, what is the general conclusion of this experiment? Well, there are different ways in which you can answer that. Alright, I'll just give you two versions. You can say that the amino acid sequence of a polypeptide chain contains all the information required to fold the chain into its native three-dimensional structure. Or you could have simply said the primary structure determines the tertiary structure of a globular protein. Anything along those lines will be absolutely correct. Hey guys, so that's it. That's the end of the question there. I know you all are bright guys out there, so you probably had all these answers. So well done, 10 out of 10. If not, that means don't worry. That means you have some little things to go and learn. Again, you could go to the Biochem GM channel, check out proteins and amino acid videos there. You get some of the information, not all the information there. Also, read your textbooks, check other videos online, and you're going to get a real feel of this. Now, this was the first one of the Biochem bloopers. Please send me your comments. Let me know how we could improve this service for you all. Alright. I'm really willing. I'm hoping that this really is helping you all. Let me know. So look out for more videos to come out soon. I'm working hard over the holidays. I'm trying to get this out to you guys. So until next time, take care guys.